Okay, let's start. There are not too many folks yet, but I hope there is no technical difficulties and maybe people will join. Uh, I hope you can hear me as well. So, welcome to this virtual meetup of Azure Stockholm. I'm your speaker for today, and the hosts asked me to introduce you to the group and just say that we have great sponsors of the meetup on the right side of the slide. And you should definitely subscribe to the group YouTube and Twitter accounts that you can find on the meetup page, and also follow the meetup page as well. Okay, let's start. So the topic of today's meetup is my talk about Pulumi, a tool for infrastructure as code management for Azure, but also for other clouds as well. So I'm going to talk a bit about how you can create the provision resources in Azure for your applications. A bit of a background story. So the topic is a very DevOpsy sort of, but I come from a application developer background. I've been always working on things like websites, web services, data processing systems for business applications. And I used to work in like smaller teams where developers and more of operations IT people would collaborate in delivering their applications to the end users. And most of the time, these applications would run in our own data center. So we would have a bunch of VMs or physical machines, some databases and whatnot, storage, and we would manage and deploy our applications on that infrastructure. And I was not operations guy, but I also was involved into the deployment process and used to be on call, so I knew how to run this thing and troubleshoot if something goes wrong. Then a couple of years ago, we started several projects of migrating those applications to Azure Cloud. So we were taking those applications one by one and sort of re-implementing them on top of Azure services. And we started using multiple services, so not just VMs, but more of like PaaS level services for things like app service or Azure functions and queues and storage and SQL databases. So what we found is that we started using much more components and much more diverse sort of components. So automation became quickly very critical. And we tried to do everything right. We automated everything. We had test pipelines, CI/CD pipeline, monitoring. And also as part of that, we also introduced infrastructure as code to our solution. And we used Azure ARM templates, so JSON files where you describe your infrastructure and then automatically provision all the resources. And I remember that just for one application that I was involved in, we had 5,000 lines of those JSON files. And the whole process of creating those files was quite painful. First, you had to find some examples online, copy paste them to your large file, tweak it a little bit, then run a tool to deploy it, wait for several minutes until it's finished. Then it probably raises some sort of error on you. And then you change something else and try again and so on and so forth. And this experience of editing the templates was quite miserable compared to what I'm used to as application developer. So I thought maybe there should be some better way of creating cloud infrastructure, which would be more developer friendly. So long story short, these days I'm working on a project called Pulumi, which is exactly aims to solve this problem, to bring modern software practices to the world of cloud infrastructure. So a bit more formally, my name is Mikhail Shilkov. I work as a software engineer at Pulumi. My main concerns there are Azure support and also .NET SDK. So today I'm going to be showing you examples in .NET and C# in particular. But Pulumi as a tool supports multiple languages, as I'm going to explain. And my general preference in cloud goes to serverless services, so things like Azure Functions and AWS Lambda. So you will see those examples in my slides. Also, I'm a big fan of functional programming and F#. If you have any questions during the talk, you can ask them in chat window and I will respond after the talk. And then if you have questions afterwards, you can always reach out to me on Twitter or on email that you see on the screen, and I will also give you the links at the end with all the slides and all the contacts. So the agenda is simple. I'm going to show you the demo of Pulumi and explain why I think it makes sense and why it's a useful tool in today's world. And then we sort of try to structure the features of the product around what we call superpowers, just to make it a little bit more fun. So I'll explain how the tool helps you provision, architect your applications, but also test and apply policies and deliver it in production environments. But first, we'll start with a bit of a theory, like why this makes sense at all. So cloud has been very impactful for the IT world. It changed already the way people create applications and deliver applications in their companies. Cloud started with infrastructure as a service with EC2 machines on AWS and then Azure and Google. And most migrations would be just lift and shift. So they would take the applications from their own data center and without changing anything, they will bring them to the cloud. But this approach is already not considered modern these days. And now the whole class of applications, which is called something like cloud native, appeared. So it's more, the applications are engineered from day one for the cloud and take advantage of the cloud elasticity and the diversity of the managed services. And every cloud has like hundreds of managed services and several hundreds of resource types. So it gets more and more complicated to manage all this complexity. And probably this is not the final state of the cloud game, so to say. In the future, of course, I don't know what's going to happen, but I expect that cloud providers will try to meet application developers closely, so provide some even more easy to use and specialized solutions for different types of applications, from web applications to machine learning and whatnot. So, so that they could take advantage of the most powerful computer ever as easily as possible and as many developers as possible. What's particularly great about the cloud that everything is automatable. Azure comes with Azure Resource Manager, which is an API to create all types of services. Doesn't matter what kind of service you need. There is a REST endpoint somewhere, and if you make a request to that REST endpoint, you will create a resource in Azure in several seconds or several minutes. And doesn't matter which tool you use to provision those services, from the portal to some third-party solutions like Pulumi. You will in the end call those APIs indirectly. Calling them directly, of course, is too low level, so you need a good tool to abstract away the exact mechanics of REST API. The most primitive tools are probably SDKs and CLIs. So Azure comes with a bunch of SDKs. This is an example in CSharp, I think, where you can like write a CSharp program, and then while it executes, it will handle creating those HTTP requests, sending them, and translating HTTP responses to your classes. So you get all the nice goodness of CSharp or your favorite programming language, but it's still on the same abstraction level of request response workload in the cloud. If you are more from operations background, you will probably use IaC CLI tool to create resources, but it's the same thing. Instead of writing programs, you write bash scripts or PowerShell scripts, and then you call commands from that script. And both SDK and scripts have a bunch of challenges. First, it's very low level or very imperative. Instead of describing your desired configuration of the environment, you have to exactly explain inside the script the step-by-step plan of how to get there. So instead of describing your configuration, you describe steps to create that configuration. And it gets quite complex. It works fine for a new project, but when one application exists for many months or years, you start to write a lot of upgrade scripts from state n+2 state n+2 to n+1. And then you manage multiple environments, so you get some conditionals in there, and it gets very complicated. Also, if your script fails somewhere in between, in the middle, you don't really know if you can run it again and get the same result, or like what's the current state of your environment, how to recover from that failure, and so on. So it's also error prone and hard to manage. That's why a long time ago already the cloud, and not only cloud tools, came up with the notion of desired state configuration tooling. So instead of describing the steps of what to do, what to create, you describe your target state. And it doesn't matter what's your current state of the environment is. There is a tool which knows how to read your target state, compare it versus the current state, and figure out those exact steps that need to be taken and apply them automatically in the right order and so on. It's useful to think about these states as graphs of resources, where every node in the graph is one resource that you want to provision, and every edge or every arrow is a dependency between the resources. And dependencies are important in order to figure out which operations tool has to make, and like what's the exact order, and whether an operation could be destructive and affect other resources or not, and so on and so forth. So thinking in terms of graph is a good way to reason about those tools. Traditionally, all the target state description is made in some sort of configuration language. And every cloud, every tool has its own language. Azure has ARM templates with JSON. If you are in AWS world, there are CloudFormation with JSON or YAML. Kubernetes is all driven around YAML config files. If you know Terraform, they have their own language to define resources, but more or less it's the same thing. It's a text file where you have to put the right properties and right values, and then give this to the tool, and it deploys the resources. However, with the markup languages, text-based languages, there are a bunch of problems as well. So first, when those tools are just introduced, there are no reasonable editors or error handling tools and so on. So they start from basically zero. It's just a text file. And then, of course, Microsoft tries to build VS Code extension to help you cache the errors and type your ARM templates faster. But every provider basically starts from scratch and creates their own tools. And of course, they are still not on par with something like Visual Studio for C#, which exists for decades already. Also, it's pretty hard to discover the exact contents of your markup file. So basically, you usually have to find some docs or examples online and start copy pasting snippets from there to your definition, because there is no way to create reusable abstractions in there. And also, the markup is still operates on a low level. So just creating dozens of resources creates very large files. And if you get to like hundreds or thousands of resources, it becomes pretty much unmanageable at that size. A quick example, I compared the implementation of a simple serverless application, a URL shortener, so something like aka.ms, bit.ly, and so on, where you go to a simple URL, and then it looks up in the database the full URL and redirects you in the browser. So application-wise, it's a very simple application. You just need like 20 lines of JavaScript or C# for that. But in terms of resources, you need to create Azure functions with all the storages and app service plans, and like a key value store, and all the permissions and all the endpoints. Or the same story goes in AWS actually. So the amount of markup language that you need to put there to describe your resources is like order of magnitude more than application code. And of course, me as a developer, I want it to be the other way around. So I want to write application code, but not to be too much focused on writing JSON templates. So that's the idea behind Pulumi, is that we want to reverse this and make it easier to author your Azure or other cloud definitions. So the main idea here is that instead of using markup languages, we use general purpose programming languages to define infrastructure. At the moment, we support 4 runtimes, so Node, Python, Go, and .NET Core. And Node means a couple languages like JavaScript and TypeScript, and .NET Core, any language is good enough, CSharp, F#, or Visual Basic .NET. And I had to pick one for today's presentation. I picked CSharp, as I said. Probably most Azure users are familiar with .NET. And also that's something I'm working on myself. But just to reiterate everything that I showed today, if you prefer a different language, you can also do it in, say, Python or TypeScript. Pulumi supports multiple providers, so this is Azure Meetup, so I'm talking about Azure and all the examples are in Azure. But you can also do AWS, GCP, or even things which are not exactly the cloud. So you can deploy, let's say, a container, a service in your Azure environment. You can build a Docker image. You can put that image to the container registry. You can deploy a Kubernetes cluster and start deploying Kubernetes pods or services, and do it all from one program in Pulumi. So we can manage different types of objects and manage the dependencies between them. And that comes pretty much for free automatically from the tool. So it's quite powerful, even if you are not using, say, Azure and AWS at the same time. So a very simple Pulumi program would look very much like this. That's rather a snippet than full program, but it doesn't matter. So this is C#, and the program is just a C# file, and it creates a bunch of objects from classes. And the classes are provided by the library, and then you just instantiate constructors, say new resource group, giving it a name, and that's all you need to define a resource group. And then the storage account would accept a couple more arguments, but it also would point to the resource group above as a property. So just by using the resource group variable here, we define the dependency in the graph between storage account and resource group, so that Pulumi knows which one has to deploy first and which one has to go second after the first one is done. And the most important thing to understand here is that this is still desired state configuration. So it's not similar to our SDKs, Azure SDKs that I showed you before. It's that by running this program, you will get the structure of the graph of the resources. And then you have to give this graph to the tool, which will be able to compare it with your current environment and give you hints about what's going to happen and like what kind of updates you have to run. So at this point, I want to switch over to a demo. I'll go to the CLI. So I created an empty folder here, and then I have Pulumi installed on my machine. So I'll run Pulumi new to create a new project. It will ask me what kind of project I want. I want Azure C# in this case, and then all the defaults go. So it will bootstrap all the files for me. And in the end, I should get a C# project with a couple of C# files. So there is a new version apparently, so it installs that. And then I can run any IDE that I prefer. I'm using a JetBrains Rider, but you can also use Visual Studio or VS Code or something like that. Sorry, it opened on the wrong screen. So I'll just move it over. Just a second. Yes. So this is the project it created. It's a C# project with basically 2 C# files in it. It has program.cs, which is almost empty. It just says that that's a console application with a main method. And all it does, it calls Pulumi deployment.run async and gives it a stack. And the stack is actually the file that defines all the resources that I need to deploy. And here generated some already examples. I will just go ahead and clean up to start basically from scratch. And stack is like a container for all resources that are deployed together. And I have some snippets prepared so I can avoid typing too much. And my goal here is to deploy a static website to Azure in a storage account. So the first thing is very similar to the snippet that I showed you before. It creates a resource group with the name my site and then a storage account. And I say that please make it a static website with index document called index.html. And then on my disk, I have a www root folder with 2 HTML files, index and company, and that's what I want to deploy to Azure. Next, I want to go through the contents of that folder. So it's just a C# file, so I can use standard libraries, I can use any NuGet packages that I want. In this case, I just use directory.get files to list the files. And then inside the loop, I can go ahead and start creating blobs to put them into a web container inside the storage account. So for every file in the loop, I create a blob resource and deploy it with the contents from that folder pointing to that file. And then finally, the final step for my program, I need to export the URL of the website because I don't know it in advance. It's going to be defined by Azure. I need to export it from my program. And the way I do it in Pulumi, I define a property for the stack called endpoint in this case. I say that's an output with an attribute. And then I assign the value of it from the storage account primary web endpoint property. And you can see that I get all the IntelliSense, all the hints while I'm typing. If I make like a typo somewhere, it's gonna show me red squiggles and will not compile. So I get immediate feedback. And writing this from scratch, even without the snippets, is much easier than writing something like JSON. So that's my program. Now I can go back to the CLI and I type Pulumi up, which will find my project. It will compile that project for me with .NET Build, and then it will run the program. And the result of the execution is going to be that graph of resources that I defined with my code. And before creating it, it will just show me the preview. This is just the preview. Nothing is created in Azure yet. It says, okay, I'm going to create a stack with a resource group, a storage account, and 2 blobs inside. Is it what you want? Yes or no? Now I'm pretty happy with what I got, so I'll go ahead and say yes. And this time my program runs again. It creates the definition of those resources, but the engine will translate that graph to the actual Azure commands. So it knows that my environment is new. I just created a new program, so there is nothing to compare it with. It just has to go ahead and create all the resources in Azure as it goes. And it knows that the resource group has to be created first. I didn't have to specify this explicitly in the options, just by the nature of the program. Resource group was defined as a variable first, and then storage account was pointing to it. So it knows that now it has to create a storage account, and blobs will only be uploaded after the storage account is created. So it's the desired state in action and graph management in action. So this is done, and the result of my program execution is the endpoint that I got, and that's some auto-generated URL, but you can see that my site is already deployed and it's up and running in the cloud. To make it a bit more interesting, let's change the program. So let's say I want to add something to the storage account like tags, for example. And I want to tag it with, again, you can see IntelliSense. If my type is wrong, I will get a hint about this. So I'm saying that this is a production, or it even found the typo. And then this time I want to update my environment instead of creating new resources. I only had to change just one line of code. And now I can run Pulumi up again. And this time it will run the same program. It will get the same graph, but with tags on it. And then it will compare that target state with the previously deployed current state of my environment. And it should figure out that, yes, my storage accounts changed, the difference is tags. And also it's not sure, maybe the output of the program will change because I'm changing the storage account. In fact, it should not change, but that's up to Azure. And if I had yes, then the storage account is updated in place without deleting any files or anything like that. And after the update is done, it will print again the output endpoint. And I'm pretty sure that Azure will keep the same URL, but we don't know yet until we get the response. Yes, the URL didn't change. So my resources are deployed. So that's the idea behind Pulumi and how it works. Let me come back to the slides. So to explain it a little bit further how this works, so we have program.cs that I wrote, or rather my stack.cs as well. And there is a language host which is specific for the language. In this case, it knows how to compile .NET and run the .NET program. And the result of that execution is just a graph of the definition of the resources that I want to create. Then there is a CLI, which also includes the engine. That's why I need this CLI. That's why I need to cannot just run my program. There is a CLI that gets a target definition and it knows how to compare to the previous state that is stored somewhere and figure out the exact operations that need to run in the cloud. And then it calls a provider because we are provider based. So there are multiple providers. It calls the Azure provider and saying, hey, please create a resource group, or hey, please update the storage account, and so on and so forth. That's multiple components working together to produce the result in my Azure account. Now, of course, you already got the idea, but the great benefit here is that you can use the tools that you love and you know already. So if you are a .NET developer, you can use all the goodness of .NET. If you are a Node developer, you will get the same tools, but for Node. So .NET Core, any operating system, any language that you prefer, any IDE that you prefer. You get things like refactoring and lynching and whatnot. And also you can do things like package managers. You can create your program with a component library, share it with your colleagues, or maybe share it with a larger community, just with a public NuGet. And you also get things like unit testing that I'm going to show in just a couple minutes. So the full power of the runtime for cloud definitions. If you're writing CSharp, your code will look like this. You already saw that in action. If you are maybe a F# developer like myself, the idea is very simple. It's a different language, but like you create objects in F# with F# syntax, and you pass data along, and it still works because it still compiles to .NET Core, and basically Pulumi doesn't care which language it was. If you are VB.NET developer, same deal, just a different syntax. It compiles to .NET Core, and you can run it as well and use it inside your company. So partially because why this makes sense is because you can create abstractions on top of low-level things. We provide a full library of .NET resources, but sometimes that's just too low level for you to reason about. For example, if you want to deploy an Azure function for something like a URL shortener that I described before, you have to provision 5 resources in Azure: function app, consumption plan or service plan, storage account, storage container, and the blob with your application to store and point inside the function app settings. And also you need the resource group to put this on. So you don't want to define all of those again and again and again. So you can go ahead and create a component. I did that just for illustration. I called it archive function app because it deploys a function app from an archive on your disk. And it does just assumes all the defaults. It creates all those resources inside that component. It's just a class in C#. And then all I need to do is pass a path to a folder on my disk where the binaries of my, or rather the source code of my function app, or binaries, I think so, resides. And if you run it with Pulumi, you will see that it will create a component called archive function app, but also will create a bunch of resources inside of it. Of course, you still need to understand what's going on here, but you don't have to write the code again and again. You can create it once and then share it with your colleagues or with the community. And it can be as simple or as complicated, as flexible as you need it to be. For example, I created a second setting on the component options called Runtime. By default, it assumes .NET, but if I want to run Azure functions in JavaScript, for example, I can say Runtime Node, and then the component knows what kind of application setting it have to set, like how to configure the plan to run my Node application instead of .NET application. And for me, it's just a setting here, which is a string or could be enumeration in this case, that I have to set from my client final application. And of course, I pointed to a different folder on the disk, and that's all I need to start deploying a different type of Azure functions. If I want to deploy Python Azure functions, that's going to be a bit more complicated because those require Linux, and by default, my component defaults to Windows. So I have to define a separate plan manually, which says like kind Linux and dynamic for consumption. And then once I have that variable, I can pass it as an extra option to the same component. And you can imagine something like an if statements there, which says if this plan is defined, use that one. If it's not defined, then create another default consumption plan on Windows or whatnot. So it's again as flexible as you need it to be, and abstracted away all the nitty-gritty details of Azure resources. On top of that, instead of just creating components, you can also start testing them because that's just your .NET code. You can, of course, test it by deploying and making sure that your application works as expected, but that's sort of slow and error-prone. You still have to do this sometimes, but you cannot cover all the scenarios with integration testing. And with Pulumi, you can write also unit tests where you mock everything. You don't actually deploy anything to the cloud, but instead of that, you just inspect the shape of the objects that your program creates. In this example, I wrote like an unit test, which calls deployment test async instead of run async with everything mocked in my stack. And the result of that call is not something being deployed, it's just that graph of resources that I was talking about. It gives me a list of resources that my program is about to create. And then this test finds a resource group there and it checks the tags, are there like if there is an environment tag inside the tags, and fails if not. And this test runs in several milliseconds, so you can run hundreds of them in 1 minute and run it in your CI/CD pipeline and make sure that you are not breaking stuff as you define new resources. Another example, this is in TypeScript, but I could convert it to CSharp. You can do any kind of logic in this unit tests. For example, in this case, I want a disaster recovery for my Cosmos DB accounts, and my requirement, maybe by law, is that the data centers that I use have to be at least 500 kilometers apart, like for in case of disasters. And my unit test can get the locations, then it can check the data of Azure data centers, find the latitude, longitude, and then calculate the distance between two locations and fail if it's not far enough. So even complex logic like this can be inspected in unit testing manner. And there is a whole blog post which describes the details. There is a bunch of details about mocking and how you can test your resources, but there is a blog post that describes this. The URL is going to be in the final links that I'm going to share. And also you can make it one step forward. So instead of just writing unit tests for your single program, you can say if you're work in a larger company with multiple projects going on at the same time, you can start defining policies for your deployments in the company. So instead of doing something like JSON-based Azure policies, you can use the same general purpose programming languages to define the restrictions of what you can deploy. You can define something in terms of pricing or which resources are allowed, or things like which ports are exposed from virtual machines and whatnot. The exact details are not that important. You can do anything because you are just using code. And then once you wrote this, you can deploy it once, and then every deployment before running any updates, it will check the graph definition versus those rules. And if the rules are violated, your deployment will be canceled and nothing will happen. So people like security folks or operation folks can maintain a set of rules and then sort of put the guardrails around application developers and be sure that they are not violating company rules just by the fact of the code which runs before every deployment. So a few words how this works in practice and production, how you deliver your Pulumi definitions to production environments. First thing I have to explain is that there is a notion of state here. So Pulumi keeps its own state. Every time you deploy something, this state is updated. And by default, it's stored in Pulumi SaaS backend service, but you can also store it in something like blob storage in Azure or on a local disk as well. And every time your CLI runs, it loads the state from the storage and compares it with the target state and figures out the difference. So in case you, let's say, store it on your local disk and then you delete that file, you basically delete your state and you have to start from scratch by importing that state from Azure, which is sometimes a non-trivial process. So to reiterate the components of Pulumi, there is a CLI that you have to download. Of course, there is your program that you have to write. Then there are providers that are interfaces to the cloud, to Azure or AWS or Kubernetes and whatnot. And there is also a SaaS backend that Pulumi provides. So all the components are open source except the SaaS backend. And SaaS backend is, you can think of it like GitHub for your Git, where you have team collaboration features, permissions, who can do what, policies and whatnot. And this thing is not open source, it's free for individuals, but paid for companies. But you don't have to use it if you don't find value in that team collaboration features. CLI is open source, so you can use it for free for any kind of purpose. Now, the deployment process looks like this. If you are a developer just experimenting, it would work very much like I showed before. You would have it all installed on your developer machine with all the tokens to access Azure, just AZ login to get those tokens. And then you deploy immediately the resources in the cloud. Hopefully for production, you don't have such access, so you would probably commit your code to CI/CD, to your Git, and then your CI/CD pipeline would run your tests, deploy it maybe to staging first, and then when you hit yes, it will deploy to production by using the keys that you store securely somewhere inside the CI/CD pipeline or related products. We have like 20 or so integrations with different CI/CD products, Azure DevOps, something like Octopus, GitLab. Everything works pretty smoothly. And to say it again, the same program or the same set of programs in Pulumi can deploy components across different tiers, from like networking, compute, and application tiers while you deploy the same application, but also across different types of compute, for example, from VMs to containers to serverless and to some data storage. And that's very powerful when you have a footprint across multiple layers and you want to manage them in one consistent way. So a good example of this is Kubernetes. Kubernetes is pretty complicated infrastructure components. So in order to deploy anything to Kubernetes, you have to deploy first things like networking and storage in the cloud. And that's probably managed by your operation people and doesn't change that often once it's done. Then you have your AKS cluster and probably some managed services like Cosmos DB for data storage or Key Vault for secret storage. And then on top of that, different teams start deploying applications to that AKS cluster. So every layer here would probably be a separate Pulumi stack because it's deployed at different time by different people. It could be just one program, but that's not practical because it's going to grow large. And then you have to grant permissions to everyone, basically. In reality, probably operations folks will have their own stacks. They may use even a different language if they want, like they define Pulumi programs in Python. And then your application developer start creating Kubernetes objects with CSharp or TypeScript, for example. So in this case, we have a notion of stacks. Stack is just one deployment. And stack references are when you need to load some information from the previous stack to the next stack. So now there is a graph of stacks in addition to the graph of resources in every stack. And there are dependencies between stacks. So if you need to deploy Kubernetes, you need to deploy networking first, then load some networking information from that stack to AKS stack and deploy AKS, load kubeconfig from that stack to your application stack. And now you can use that kubeconfig to connect to the cluster and start deploying the applications. So in real-life applications, they consist often from multiple stacks operating with each other. And I want to show a very quick demo of this. So I'll switch back to my Rider IDE. We'll open a different project. That is like a very simple implementation of the diagram that I showed you before. So I have just three projects in this case. One cluster deploys the AKS cluster and everything that needs to go with it, and then two application projects to deploy to that cluster. And the cluster stack is again just a class in C#, and it defines all the resources that I need for AKS, from like SSH keys, Azure AD, service principals, passwords, virtual networks, subnets, and AKS cluster itself. So in reality, it's going to be more resources, but that's like the minimal footprint for AKS. And then the result of this execution is that kubeconfig is going to be assigned to the output property that I defined somewhere on top of that. So the result of the execution of this stack is kubeconfig that you get after deploying an AKS cluster. I'm not going to deploy it now because it takes some time. You can imagine it's deployed and then you get kubeconfig from it, printed on your CLI, but more importantly, it's saved in stack outputs. And now the second stack, which is created by an application developer, can create a stack reference and then point it to that cluster stack that I just created. And from that cluster stack, it can require an output called kubeconfig. And that will give me a string with the kubeconfig that I should use as a connection string for my application objects. In this case, I can create, I want to illustrate that I don't have to define everything as Pulumi objects. I can also use things like Helm charts from within the same program, and it's going to be managed by Pulumi. So I create a Helm chart by specifying the options that I get with the kubeconfig at the top. And when I run the stack, it will deploy that Helm chart to that cluster that was created by a separate stack. So that's about it. Just to wrap it up, some conclusions about what I showed you before and why I think Pulumi is an important tool in the modern cloud native world. So developers get more and more involved into cloud provision and cloud application development, and they want to use the same tools, practices, and abstractions that they are used to. And this also allows operations people and developer people find a common ground and work together. So the idea of DevOps movement shines here. So if you are a developer, you can use familiar language with all the toolchain, and then also create higher level abstractions that would work on the same level of your, let's say, whiteboard diagrams, something like archive function that I defined before, or an AKS cluster that I showed you after. And also you can reuse testing approaches that I used to with unit testing or integration testing to make sure that what you are about to deploy actually does what you expect even before you start the actual operations in Azure. Just to give you a sense about what kind of applications we see in the real world, well, first, people take advantage, of course, of those components and reusable patterns that they apply across multiple applications or across multiple teams. They sit down, they discuss what kind of patterns they want to apply, and then codify it in their code and reuse it as a separate library within the company or outside it. Then it's very common that in larger enterprises, there is like a platform team that defines the structure of components that other teams should be using and like create a reusable bricks for them. And you can think of those again as a library that folks that are very familiar with cloud create for other application developers that might be newer and don't know all the intricacies of the cloud resources, Azure resources. And finally, even cases like SaaS platforms where they need to provision cloud resources per tenant. So let's say they get a separate customer. A good example of this is CockroachDB that I use in Pulumi behind the scenes. So every time you create a cockroach DB cluster. They have to provision a bunch of resources in the cloud, and that can be another stack deployment behind the scenes. So whenever somebody buys something at Cockroach, they would run a Pulumi program for a new stack and provision a bunch of resources automatically. And you can imagine they have like hundreds or thousands of those stacks. It would be pretty painful to manage all this with like JSON files and more traditional markup languages that are not very human creatable, let's say. So if you want to go back to what I showed you before, you can go to that link, bit.ly/Pulumi links. It's a Git, like a GitHub gist with multiple links, and there are 2 slides, but also getting started guides, my contact details. And if you have further questions, feel free to ask me on Twitter or email me or go to our communities. Like there are like 2,000 people there which can share their experiences about the tool, and a bunch of blog posts that are related to .NET and Azure as well. So with this, thank you for sticking around for this session. I wish I could go to Stockholm in person, but this time it has had to be virtual. If you have any questions now, I can check the chat window. I'm not sure if there was anything there, but if not, feel free to reach out later on, and have a lovely evening.
Can we take questions?
Yes, sure.
Yeah, questions are open. So anybody who have any question, you can ask now.
I see one question in the chat. How does Pulumi compare to AWS CDK and Terraform in terms of functionality? Okay, great question. So Terraform is like for people who might not know those tools, Terraform is a tool which is in the same space, so infrastructure is called for multiple clouds. And instead of just general purpose programming languages, they use their own markup language. So that's the most striking difference. We actually use all the Terraform. A lot of current providers for Pulumi are based on Terraform providers. So if you any Terraform provider basically can become a Pulumi provider with like a bunch of small configuration. So if you know that there is a Terraform provider for your favorite tool, then you also have a Pulumi provider for that. But you can use all the general purpose programming language infrastructure that we created instead of using HCL. AWS CDK is a tool from AWS, which is similar to Pulumi because it uses general purpose programming languages. It's different in implementation. Well, first it was driven by AWS, so it's mostly used for AWS deployments. The way it works, it generates CloudFormation templates. So it generates templates, and then deployment tools deploy those templates to AWS. And that sort of limits the things that you can do inside your CDK programs that are not expressible in CloudFormation, basically. So in Pulumi, it's just code that deploys resources directly in the end. So you could also create your own resources. You could do things like shell out to Azure CLI and whatnot, or do like a custom tool that you created. It's more complicated than AWS CDK, but in this sense, they are similar. Now, I believe CDK also released something for Terraform, like there is a Terraform CDK or something like that. It's like very, very early preview version, but then it's like a combination of both things where you have general purpose programming languages for Terraform. So if this gets some traction, it could be comparable to Pulumi, but it's like, I think it was released like a month ago. I think they are sort of seeing merit behind what we are doing and trying to catch up in some sense. So we'll see how that develops. But I would say Pulumi is more mature at this point than CDK for Terraform. But those tools are all comparable. So in a sense, if you want to use them at your work projects, it makes sense to just try all of them and see what works best.
I have one question regarding the policies you showed.
Sure.
Do we do you convert these policies into Azure policy or a cloud platform version, or is it's only Pulumi specific?
No, that's a very Pulumi specific thing. So if you're trying to deploy something outside Pulumi, like if you have all the levers to go outside, you will not, these policies will not be applied. So they are more expressive than what we can express in Azure policy as far as we can tell. So we cannot convert them, and we don't. So they are also applicable across clouds and across tools. So it's a trade-off. Like if you are on board with Pulumi and you use it for everything, then those policies will always restrict you. If you're like halfway through, maybe they will only make sense for your deployment in Pulumi. That's a specific tool.
Great, but do you have any like insight about other customers? Like how do they use it? Do they put it in their pipeline, and some central platform team, as you mentioned, manages policies as well? What is the best practice?
So from what I heard, usually these policies are like created by separate people. There are people that care about, say, security, or cost is another example, and they write these policies. And there is like, I think we have like a bunch of pre-built policies for AWS and Azure where you can like either get inspiration from or reuse them as is. And then they put it, so if you are using Pulumi SaaS product, then you can just upload those policies there, and they will automatically apply across the companies, and you can like assign them across multiple teams and whatnot. So like more team collaboration stuff. Or the second scenario is that you just put it into your CI/CD pipeline, and you configure it to run for every, say, built-in master or like PR or whatnot. And you can also configure it per environment with different requirements. So it limits development environment differently.
Thanks.
Any other questions? Okay, I guess that's a no. So thanks everyone again. Feel free to reach out to me after the session if you have any questions. And thanks for having me in Stockholm virtually.
Yeah, actually, we wanted to have you physically, and you remember we tried that.
Yeah.
But we will have you physically as well very soon. So
yes, I hope so.
I'm hoping for the next year. So
sure.
Yeah, thank you very much. That was really knowledgeable and valuable session. And yeah, thanks a lot.
Thank you. Bye-bye.
Bye-bye.